Hey guys, how you doing? So welcome to this unit on kinematics. So in this series we're going to be looking at five different lessons, and the first one is going to be on speed and velocity. So let's jump into it. Okay. Whenever you see me talk about one of the subheadings, you'll notice that I'll put the little formula there. So in this case here, speed has the formula S equals d over t, and that there is just a little bit of a drone footage of a car racing for you for your entertainment. Let me go to the next slide. All right, so let's take a look at what speed is. Yeah, defined as the change in distance over time. Yeah, here's a formula: S equals d over t. You're going to encounter a lot of formulas and probably a lot of calculating and maths, so you're probably going to have to get used to it. So feel free to pause the video and have a go at these questions whenever you get the chance to. Okay, so let's take a look at what this formula actually means. So speed, the S, is equal to the distance over time. It's basically how much distance an object is going to cover over time. Yeah. In this particular case here, let's say, for example, when we measure distance, we're going to measure distance in meters, represented by the letter M, time represented in seconds, and so the speed, the movement of the object, is how many meters it will move over 1 second. Yeah. So it's meters per second, and you'll notice that it is represented by this two symbols here. It can be the m/s or ms to the power of -1. They both actually mean the same thing, and you guys will just have to get used to the fact that if you see one or the other, you can derive that they mean the same thing. Okay, so let's go with an example. So for example, if we wanted to calculate the speed of a cheetah that ran 70 meters in 3 seconds, we want to find out how much distance the cheetah has covered in a single second. Then you can work that out by dividing 70 by 3, which equals to 23.3 meters per second. Okay. If I wanted to figure out the speed of a Lamborghini, that takes 51 seconds to travel 5,000 meters, which is about 5 kilometers. Then you can divide 5,000 by 51, and that'll give you a speed of, I don't know why it keeps doing that, but you're gonna have to live with it. 98.04 meters per second. That is, every second the Lamborghini has traveled about, just under 100 meters. Okay. What is Marcus's speed? If he runs 100 meters in 14 seconds, it would be 7.14 meters per second. Yeah, so that's how you would calculate it. You simply divide the distance by the time. Okay, let's move on to the next slide, because I was getting sick of that GIF, to be honest. All right, now a couple of things we need to understand before we actually go through the calculations. You would have come across this probably in maths, but I'm going to cover it again just for the sake of this unit, because it applies not just for speed, but for all the other formulas you're going to come across as well. One of the most important things that you must kind of understand when it comes to formulas is that the units must remain consistent between all of your variables. Yeah, the unit for distance, if it is meters, and the unit for time is seconds, then the unit for speed must be meters per second. Yeah, so you have to try and match units required of the variable that you're trying to find out, and if they are not the same units, like for example, if distance was done in kilometers, then you have to convert the units before you actually do any calculating. Okay. If there are no units specified, for the sake of simplicity, whether in these videos or in class, you can assume that it's either in meters per second or kilometers per hour. Okay. Now this is a very handy little infograph that you can refer to move between the units. Yeah. So a very simple way of looking at it is like this. There are about 10 millimeters in every centimeter. Yeah. So if I have 10 millimeters and I want to figure out, well, how many centimeters is that? I simply divide it by 10 when moving across the arrow like so. Okay. There are about 100 centimeters in every meter, which means if I have, for example, 200 centimeters, I'm going to divide 200 by 100 to give me 2, and that will be how I move from centimeters to meters, and that will be 2 meters. If I have, for example, 3,500 meters, and I want to figure out how many kilometers, I know that there are about 1,000 meters in a kilometer, so I divide it by 1,000 to give me 3.5 kilometers. Now, if I want to go from kilometers to meters, I simply multiply it, and the number will get bigger. Yeah. if I am wanting to convert kilometers per hour into meters per second, they are actually two very different units. And so learning how to convert them in a quick manner is really important. So I'm going to show you the long way of doing it, and then just quite simply, how to go about it in a very quick way, okay? So if you were to come across a question that asks, okay, what is 100 kilometers an hour in meters per second, you have to actually convert both the kilometers into meters and the hour into seconds. How you do that is 1 kilometer per hour can be written as 1 kilometer over 1 hour. If we convert, for example, the kilometers into meters, that will give us 1,000 meters within 1 hour. And then we then have to convert the hour into minutes and then into seconds. So then that'll give us 1,000 meters over 60 minutes. And if you want to get the number of seconds in an hour, you have to multiply it by 60 and by 60 again. So then you will get 1,000 meters divided by 3,600 seconds. Now, if I simplify the math, that will give me 1 in 3.6. 3.6 here is the magic number, okay? So if you want to convert kilometers to meters, you simply divide whatever the kilometers per hour is by 3.6, and that'll give you meters per second, okay? If you want to convert meters per second into kilometers per hour, you multiply that number by 3.6, and that will give you kilometers per hour, okay? So remember, if you are going kilometers per hour into meters per second, divide it by 3.6, and then from meters per second to kilometers per hour, you have to multiply by 3.6. The general way that I remember this is that kilometers per hour is always higher than meters per second in terms of the value, yeah? So here's a few examples. So let's say, for example, you have to calculate what is 16 kilometers in centimeters. So if I want to figure out, I go kilometers in centimeters will be 16 kilometers will be 16 times 1,000, which will give me 16,000 meters, and then I have to multiply again by 100, which will give me 1.6 million centimeters. Question number 2, a car travels at 17 kilometers in 12 minutes. What is its speed? So you can see there, the question is asking for the speed in meters per second, which means you will need to convert both kilometers into meters and minutes into seconds. So if we divide kilometers into meters, you will get 17 multiplied by 1,000, which will give me 17,000. And 12 minutes in seconds, there are 60 seconds in a minute, so 12 times 60 will give me 720 seconds. And so if I divide it, that'll give me a rough amount of 23.61 meters per second. Yeah. If in doubt, always go to 2 decimal places for the sake of this unit. Okay. Last question, what is the speed in meters per second? Notice how it's asking again for the unit of a Boeing 747 that travels 13,450 kilometers in 14 hours. Okay, if you have 13,450 kilometers, right, then you can go about this in the simplified way, which is calculate kilometers per hour first, and then you're going to divide by 3.6 to get meters per second. So I'm going to divide the speed to get the speed. I'm going to go 13,450 divided by 14, and then I'm going to divide that number by 3.6, which will give me 266.87 meters per second. Okay, so if you're not sure of these calculations, I would encourage you guys to have a go at it yourself first before you have a look at the answer, and hopefully that'll be right. Okay. All right. The second aspect of speed that we need to understand is that speed, rarely stays the same. For example, if you are driving along a highway and you're going at 80 kilometers per hour, you're never really going at 80 kilometers per hour. You're most likely going to be straddling, 81 to 79 and so forth and so forth. And so what happens is, for convenience sake, a lot of times we want to know what the average speed of a object moving would be. So the average speed can be calculated by taking up the total amount of distance that the object has covered and then dividing the total amount of time that it takes. Yeah. So here's an example. Imagine if you are Oliver Gates and you live in Ferntree Gully and you take about 15 minutes to walk 500 meters to Ferntree Gully Station. Okay. Then you catch the train and it travels 20 kilometers in 15 minutes. And if I'm trying to ask, well, what is the average speed in meters per second, then what you need to do is you need to figure out two sets of distances and two sets of time. The first set of distances is the 500 meters, and then the second set is 25 kilometers, and then the two sets of time is 15 minutes to walk and then 15 minutes in the actual train. So you want to calculate total distance, total time. Right? And so there's a step-by-step process you can do that. The first thing you have to do is you have to always convert your units first and make sure that they are the same as the unit that you want in the speed calculation. So in this case here, I want my units for distance to be in meters and I want my units for speed to be in seconds, which means I have to convert this 20 kilometers into meters and these 15 minutes into seconds. Okay, so step one, I'm going to convert the 15 minutes into seconds, and that will give me 15 minutes times by 60 seconds will give me 900 seconds. Now remember, that happens twice, right? So I'll go back to that in a second. I'm going to convert my kilometers into meters. So the 20 kilometers here multiplied by 1,000 meters will give me 20,000 meters. Now I'm going to add up my total distance. 20,000 meters here plus another 500 meters here will be 20,500 meters. Total time, remember he spends 15 minutes walking, which is 900 seconds here, and another 900 seconds here, which will make it 1,800 seconds there. So speed is equal to total distance, average speed is equal to total distance over total time, giving us an average speed of 11.38 meters every second. Okay. So the last aspect of speed, and pretty much the same aspect of every formula rule that you get, is to understand how to rearrange these formulas. Okay, up until now, all of the example questions, or almost all of them, are asking you to calculate the speed if we give you the distance and the time. Now that's quite easy because if you have the formula, the speed is there on its own and the distance and the time is given here. So you simply have to divide distance by time to get the speed. However, if I ask for you, how do you figure out the distance if I give you the speed and the time, you actually have to rearrange this formula so that the distance is on its own. And so when you are rearranging formulas, the aim is always to have the pronumeral that you are searching for alone on its own on the left, okay? And then the rearrangement needs to happen through algebra to figure it out, okay? So I'm going to show you how to calculate distance by rearranging formulas and then how to calculate time by rearranging the formula. However, I'm going to make a separate video on how to just rearrange a general formula because you're going to have to apply these rules to different types of formulas, okay? So how do we get distance on their own? So the simple way that I can put it is to simply backtrack by altering both sides of the equation. So you can see here, let's say my equation is S equals to D over T. Now, theoretically, okay, if I change anything on the left side, I must therefore change the same thing on the right side. And so what I want to do is I want to begin cancelling out all of the different letters or the pronumerals until I have the one that I'm after by itself, okay? So if I look at S equals to distance over time, well, if I want to get rid of that T, what I can then do is I can multiply everything on the right side of this formula by T, because if D divided by T times T would mean that the two cancel out. However, I can't just do that on the right side. I have to apply the same rule on the left side, okay? Now, there's probably a few names for this. I simply call it backtracking, but there's probably some sort of algebra rule and whatever that you kind of use for that, okay? So if I have D divided by T, I'm going to multiply this side by T, and I'm going to multiply this side by T. And because I'm multiplying by T and then dividing by T, the two cancel out, so it becomes a cross. Now D is on its own, but what I've done on this side is that the S is now multiplied by T, right? So S times T therefore equals to D. And all I did is I just flipped the equation around so that D is on the left side now and the S times T is on the right side, which makes no difference. Both of this means the same thing, but this is just simply an easier way to read it because I've got the D on the left side, okay? So in other words, if I want to rearrange to calculate for distance, I can now figure out the distance is actually speed times the time. So if I want to figure out the distance of an object moving, I figure out its speed and I multiply the time it took for it to move at that speed. Okay. Calculating by time is pretty much the same with an additional couple of steps so that we can get the t on its own. Okay, so I'll show you the long way of doing it, and then I'll show you the quick way that I generally just kind of always figure out in my head immediately. Okay, so we're going to go from the same set of steps initially, where what you're going to do is you're going to multiply both sides by t to get rid of the t on one side and move it to the other side. So s times t equals the d over t times t. Now, the two t's cancel out once more, and I'm left with s times t equals to d. Now, once I get to here, all right, I'm going to flip the 2 around like I've done here. Yeah, so instead of s times t, I've just done a t times s. I want to get rid of the s, and I want to move the s to the other side now. So to do that, I'm going to divide both sides by s like I've done here. So t times s divided by s would remove t, right? And then, because I've done the divide by s on the left side, I have to apply the same thing on the right side, and therefore d divided by s would equal to t. Yeah, so t equals to d over s. So to calculate time, it is simply the distance divided by the speed that you are moving at. Okay, which kind of makes sense if you think about it, right? If a car is going at, for example, 50 kilometers per hour, how long does it take for it to cover 50 kilometers? Well, it's 50 divided by 50, giving you 1 hour, okay? So that's kind of how you rearrange it. In very simple terms, all I've literally done, if I want to get rid of all this in between, is I've shifted the d to move on top of the s. Yeah, so see what I've done there? I've just shifted the d over and I moved it on top. But the reason why I teach you guys all of these complex, moving rearrangement is because you're going to have to learn how to do it intuitively in the future, okay? So those are actually 3 formulas then to calculate speed. Also, your 3 speed formulas, just each one will have the per numeral you're after on its own. Okay, so s equals to d over t, or distance is equal to speed times time, or time is equal to distance divided by speed. Okay, now here's another set of example questions that you can have a go. If a car travels at 80 kilometers an hour along the highway for 3 hours, how far in kilometers has it traveled? Yeah, so always pay attention to the worded question and what it is asking at the very end or in the middle or wherever, because that's what it wants you to search for. So I've highlighted it in blue in this case. So if a car is going at 80 kilometers per hour along the highway for 3 hours, it wants you to figure out how far, which is calculating distance, okay? So to work that out, I'm going to use the distance formula where I go d equals to s times t, and I'm going to multiply my speed by the time, okay? Remember, because I'm after the unit is in kilometers, then I need to make sure that my speed unit and my time unit matches up, so that they're both written in hours. If not, I have to begin converting my units once again so that it matches, okay? So in this particular case, I'm going to write out the per numerals that I have, and then I'm going to work out the one that I need, which is distance, okay? So distance would therefore be equal to 80 kilometers per hour multiplied by the 3 hours that you have traveled, right? Therefore, it is, if you go 80 kilometers an hour for 3 hours, you multiply by 3 to give you 240 kilometers that the car has traveled, okay? The second question says, how long in hours would it take to complete a 42.2 kilometer marathon if a runner averages a speed of 9.6? So now you're after time. So you're going to use the time formula, which is distance divided by speed, okay? So distance is equal to 42.2 kilometers, and the speed, conveniently, is in kilometers per hour. So therefore, the time will be 9.6 42.2 divided by 9.6, which gives you 4.4 hours. So it takes about 4.4 hours for this runner to accomplish 42.2 kilometers, okay? Now, question number 3, the Peregrine Falcon travels at a maximum speed of 390 kilometers per hour. how long in seconds would it take to reach a pigeon located 200 meters away? Now, in this particular case, you are now doing both the conversion of units and then figure out which formula you are going to use. Okay, so let's figure out which formula you're going to use first, and then we're going to convert our units. Okay, so the question asks how long. So how long means you're going to use the time formula to figure out what the time it would take to reach the pigeon. The speed is 390 kilometers per hour. The speed we actually want needs to have seconds in it, and the distance that is being given is meters, which means we're going to convert the speed into meters per second. Okay, so the quickest way to do that is you take 390 kilometers per hour and you divide it by 3.6, and that should give us about 108.33 meters per second. Now that we have the speed, we can try and figure out the time by using this formula. Okay, so the distance was 200 meters and the speed it was going at is 108.33. So t equals to d over s. D is equal to 200. S is 108.33, which gives us a final value of 1.85 seconds. So the bird is moving at about 180 meters per second, and it only takes less than 2 seconds to get to the pigeon that is 200 meters away. Okay, so hopefully that makes sense for speed. Now, let's move on to the next formula, which is the velocity formula. Now, velocity and speed are very similar concepts. In fact, you probably hear it being used interchangeably whenever you kind of hear bits and pieces of velocity of airplanes or speed of cars or whatever. They both mean very similar things, but velocity has a slight difference in the way that we define it. Okay, so velocity is the change in an object's position or its displacement over time. Notice how it's not distance anymore, it's position. And so we use a different set of formulas again for it, okay? So I've actually got the same formula, but I've just rearranged it up to the top corner, but here's the formula here. V, which is velocity, is equals to delta x, which means displacement, written in meters, or m, over time, yeah? It is change in displacement over time. Sorry, that should say velocity, that shouldn't say speed, right? And once again, the units can be meters per second or meters second to the power of -1. Okay, now what's the difference between the two? Well, velocity is what we call a vector quantity. A vector quantity contains both magnitude, which is how much, and the direction that it's moving in. So whenever you list velocity, you have to always identify both how fast the object has changed positions, and you have to specify which direction it has changed positions in. Speed, on the other hand, is what we call a scalar quantity. In other words, it contains magnitude, but there's no direction. Yeah, a car going at 60 kilometers per hour in speed would not have the direction listed. Of course, you can list the direction, but a scalar quantity doesn't normally give direction, whereas velocity must always give direction. Okay, so if an object is traveling in a straight line, both values end up being the same. But where it gets different is if you have an object that is traveling not in a straight line and then you calculate its displacement. Okay, so if I was to look at distance versus displacement, it would be a bit like this. Distance is the ground that is covered by the moving object. Okay, so if you start here and you walk this kind of loopity-loop around here and you end here, the distance that you have covered is shown in the dotted blue line over here. Okay, however, your change in position is actually this line here. So in this particular case here, if we wanted to figure out what your displacement is, it would actually be less than your distance. It would be far less than your distance. It is simply where you were away from the original position as opposed to how much ground you have covered. Okay, and that change is represented by the letter or the Greek letter delta, which is this little triangle here. You'll see this come up again later on, but for now, that's all you need to know. Okay, so displacement helps us determine positioning, whereas distance actually doesn't tell us positioning. Yeah. So if I wanted to figure out the displacement, let's say, for example, this displacement is about 5 meters. It'll be 5 meters southeast. Okay, 5 meters southeast. Now, what do we use the two different things for? Well, it's quite simple. If you're traveling in a car, your speedometer, the one that calculates the speed that you're going at, doesn't need to know the direction that it's moving in. It simply measures the rotation of the wheels, and then it calculates your speed based on how many times your wheels have turned within 1 second, right? And so it can calculate its speed and how fast you're going using this speedometer. Okay. However, if you're turning on your Google Maps and you want to figure out using GPS, the GPS uses displacement. It looks at how your position has changed over time to figure out where you are. And so both of them are very useful for different things. If you're in a car, the speedometer doesn't need to tell you which direction you're moving in. It simply needs to tell you how fast you're going. However, if you're trying to calculate your GPS positioning using the satellites, they coordinate your change in position over time to calculate your velocity and the direction that your velocity is going in to give you a map of your movement in 3D space, or 2D space, I suppose. Okay. So give that a go. All right, that's it for this video. Next video, we're going to take a look at acceleration. I'll catch you guys then.